Welcome to another session of financial maths in the Wise Escape Academy. Today we are going to be working on compound interest. The question we should be asking first of all, what is an interest? Remember, we are in finance. An interest is an expense, a charge paid on money borrowed or an income received on money lended. Now, the calculation of interest takes into consideration the amount invested or borrowed, the duration of the investment or the loan, and it also takes into consideration the interest rate, which is actually the method of calculating the interest. So, there are actually two methods of calculating interest. There is a simple interest method and the compound interest method, which makes us to have two types of interest: simple interest, compound interest. Now, what is simple interest? Simple interest is interest calculated by applying the interest rate only on the initial investment throughout the duration of the investment. Now it means at the end of year one, at the end of year two, at the end of year three, right to the end of the last year, at the end of every period, the interest rate is applied only on the initial investment. And this also means that the interest for each and every period is constant. Unlike compound interest, compound interest is actually a method of calculating interest whereby the interest rate is applicable, is applied on the capital of the period. And the capital of the period is the acquired value of the previous period. This means that at the end of every period, the interest generated is added back to the capital of that period to form the capital of the next period. So it means that in compound interest, interest is not actually constant since interest is capitalized, that is reinvested. The interest it increases over time. So if I were you, if I want to borrow money and I'm given the chance to choose between simple interest and compound interest at the same interest rate, I'll borrow at simple interest. But if I want to lend money, I will lend at compound interest. Actually, because the total interest generated on compound interest is greater than that of simple interest, given the same interest rate, same amount invested over the same duration. Okay, now in simple interest, we are going to look on how to calculate the acquired value. Acquired value. The acquired value is also what we call the future value. And remember, on generally, the acquired value is the sum of the amount invested, which we call principal plus the interest generated. Acquired value or future value is the sum of the amount invested and the interest generated. That is the principal and the interest. But now let's come under compound interest. Remember, we say here that interest at the end of every period is capitalized, is reinvested. So let's get the following notification first. Let P be equals to the principal. Principal here is the present value. Under compound interest, the amount invested or the amount borrowed is P, which is the principal. Let's take N, the duration of the investment or the loan. I is the interest rate for 1 franc CFA. It depends your currency, maybe $1. So I is actually equals to R divided by 100. And now let A denote the acquired value. And let P, okay, P is already the principal, which is the present value. Now let's get this. Let I be equals to the interest. Now, let's see how to calculate the acquired value. We are at the beginning of year one. Let me call it Y1. At the beginning of year one, we invest. That's capital or principal. Let me call it capital. We invest P. At the end of year one now, the amount invested has to generate interest. So the interest at the end of year one is I1, which will actually be P times I. Why P times I? Remember, in simple interest is calculated by taking what? The principal times the rate times the time over 100. And now, here we are calculating interest every year. So n here is 1. And R divided by 100, like we say, is equals to what? I. So normally the interest for each year has to be what? P times I. That's why we have P I. Now, if we go straight now to the acquired value of year one, let's call it A1. This will be equals to what? The capital of year one, which is P, plus the interest for year one, which is I1. Let me put it that way before I expand. So this will be equals to, but the interest for year one is P times I. So this will be P plus P times I. P is common, so I can factorize it out. I'm going to have P into 1 plus, that's the acquired value of compound interest at the end of the first year. Let me want to print space. Now let's go to year 2. In year 2, remember, the capital of year 2 will be the acquired value of year 1. Let me call it A1. Interest for year 2, I2, which is going to be equal to A1 times I. Acquired value for year 2, that will be BA2, which will actually be what? The capital of year 2, which is A1, plus the interest for year 2, which is I2. But I2 is equal to A1 times I. So this will be A1 plus A1 times I. A1 is common. So we have A1 into 1 plus I. But A1 is equal to P into 1 plus I. So this will be equal to P into 1 plus I, which is A1 times 1 plus I. Sorry, I have to wipe this. Now, 1 plus I times 1 plus I will give 1 plus I squared. So this will be P into 1 plus I raised to the power 2. That's the acquired value at the end of the second period. Let's go to year 3. The capital of year 3 will be the acquired value of year 2, which is A2. We go to year 3, the interest for year 3, which is I3, will be the capital of year 3, which is A2, times I. Now, if we go to the acquired value of year 3, which is A3, will be the capital of year 3, which is A2, plus the interest for year 3, which is I3. But I3 is equal to A2 times I. So we are going to have A2 plus A2 times I. A2 is common, so we can bring it out. So we have A2 into 1 plus I. But A2 is equal to P into 1 plus I squared. So I write P into 1 plus I squared times 1 plus I. 1 plus I squared times 1 plus I is 1 plus I cubed. So this is going to be equal to P into 1 plus I raised to the power 3. Permit me to generalize the formula. The acquired value at the end of period N is the last period, is actually the acquired value of the entire investment. So let me write A to denote the acquired value at the end of period N. Remember, when we have A1, we have raised to the power 1, A2 raised to the power 2, A3 raised to the power 3. It means if we have AN, which is actually A, because the acquired value of the last year is the acquired value of the entire investment, it's going to be equal to P into 1 plus I raised to the power N. This is how the compound interest formula is gotten. That is how the compound interest formula is gotten. Now, permit me to wipe this. I want to do something on this side of the book. Now, how do we calculate compound interest? Remember, acquired value is the sum of capital and interest generally. This is it on the board. It therefore implies that interest will be the difference between acquired value and capital. So compound interest here will be what? A minus P. But from what we have generated, A is equals to P into 1 plus I raised to the power n. So compound interest here will be P into 1 plus I raised to the power n minus P. You can see P common on both sides. So what if I do this? P, I open a big bracket, so I have 1 plus I raised to the power n minus 1. Now that is actually going to be the compound interest. So if you are asked to calculate the compound interest directly, you use this formula. Meanwhile, this is the formula for the acquired value. And let me use this opportunity again to say this. Remember, the compound interest for a particular period, let me put n, is equals to the capital of that period. I'm using an minus 1, which is the acquired value of the previous period. Because the previous period to n is n minus 1. Remember, if we have here I2, we take what? A1, that's the acquired value at the end of year 1. We have here I3, we take A2, that's the acquired value at the end of year 2. So this will be IN, which is equals to AN minus 1 times I. But AN minus 1 will be equals to P into 1 plus I raised to the power n minus 1. So IN, n here is any period. Is that okay? Any period. If you are asked to calculate the interest for the PDM, the CDM, so this will be P into 1 plus I raised to the power n minus 1 times I. This is the interest for a particular period. So if they say 10th period, that's I10, what will be here? 9. P into 1 plus I raised to the power 9 times I. So this is how you can calculate the acquired value. This is how you can calculate the compound interest of the entire investment or the total investment. And this is how you can calculate the compound interest for a particular period. Please just glance through. We are going to start taking examples. Okay, let me wipe. Please, if you're new, subscribe to the channel. Share the link for others to benefit. The link of these questions will be in the description section of this video. The Telegram channel link will also be there. Please download, you can solve, and you send in the Telegram group. I'm going to verify. I'm going to go through. Or if you have any question, please put it here as a comment. And why not ask it also in the Telegram group. So let's go to question number 1. Here we see how to calculate the compound interest. 1 million francs is invested for 5 years at the rate of 10% compound interest. Calculate the acquired value and the compound interest and the interest of the third year. So acquired value, compound interest, and interest for the third year. Now, what is the principal? The principal is 1 million francs. What is the interest rate? 10%. 10%, which is 10 over 100, which is 0.1. What is the duration of the investment? 5 years. So, how do we calculate the acquired value? P into 1 plus I raised to the power n. Do I know P? Oh, yes. 1 million. Into 1 plus 0.1 is 1.1 raised to the power 5. How does this go? Calculator. So you punch 1.1 raised to the power 5 equals to times 1 million. 1,610,510. 1,610,510 francs CFA. This is the compound, the acquired value. The compound interest, we can take directly the acquired value minus the principal, which is 1,610,510 minus 1 million, which will be equal to 610,510 francs CFA. If we're not asked to calculate the acquired value, the compound interest will be calculated by taking P, big bracket open, 1 plus I raised to the power n minus 1, which will be equals to 1 million, big bracket open, 1.1 raised to the power 5 minus 1. And this will give you 610,510 francs CFA. Now, they also ask us to calculate the interest at the end of the third year. The interest at the end of the third year will be the acquired value at the end of the second year times the interest rate. And this will be equal to P into 1 plus I raised to the power 2 times I, which will be equal to 1 million into 1.1 raised to the power 2 times 0.1. What do we have to let me calculate? (1.1) raised to the power 2 equals to times 0.01 equals to times 1 million. That's 121,000 francs. The interest is 121,000 francs here. That's example number 1. That's example number 1. Example number 2 asks us to calculate the present value. Now, in compound interest, I would like you to know this. In brief, the acquired value is calculated by applying the compounding factor. This is called compounding factor on the present value. That's the amount invested. Meanwhile, 1 plus I raised to the power minus n is called the discounting factor. So, compounding or capitalizing factor, discounting or actualizing factor. 1 plus I raised to the power minus n. Now, remember, acquired value is still called future value. If you want to calculate the acquired value, it means we have an investment now. We want to know the worth of the investment in a future period. So, compounding means moving into the future. That's calculating future value. Discounting means moving from the future into the present or back to the present. That is why we have here raised to the power negative n. It's called discounting factor. And what do we actually discount? The future value. So, let me use this opportunity at once to say this. Let me wipe off. We have space. The present value P will be calculated by discounting the acquired value. 1 plus I raised to the power minus n, or by applying the discounting factor on the acquired value. Now, what does this mean? It means if I take this acquired value here, if I take this acquired value here, 1,610,510, and I apply the discounting factor on it, it must give me the 1 million. Let's try. 1,610,510 times 1.1 raised to the power minus 5. Let's go. 1.1 raised to the power minus 5 equals to times 1,610,510. 1 million. 1 million. This formula can still be written like this. A divided by the compounding factor. A divided by 1 plus I raised to the power n. A divided by 1 plus I raised to the power n. Can we see that? Yes. So it's either to calculate the present value, it's either we take the acquired value divided by the compounding factor, or we take the acquired value multiplied by the discounting factor. It still gives the same thing. But I always love using this. I always love using the discounting factor because it actually shows the effect of moving from right to left, which denotes this negative sign. You are moving from right to left, moving from the future and coming back into the present. Whereas compound in the acquired value, you move from the present into the future, compounding. So that is it. So from the acquired value formula now, we are going to see how to calculate the duration and the compound interest rate. Let me wipe the board. Please don't forget or remember, the link to this question will be in the description section of the video. Share the link, subscribe. Compound interest simplified. Okay. Now, calculation of the duration n. Now, to calculate other values from the acquired value formula, the other values we are talking of here is mainly the duration and the compound interest rate. We can use financial table 1, which is the future value at compound interest. Financial table 2 is the present value at compound interest. So we can use financial table 1, and this one you can easily punch. So you can either use the financial table or you go directly with the acquired value formula, which is what we are going to do here. And when you go directly, there's an option you can use log or otherwise. But with the duration, since the duration comes in the formula as a power, as an exponent, you must apply log. Now let's see how that goes. Recall that the acquired value is equal to P into 1 plus I raised to the power n. Now the first thing we have to do, divide both sides by P. If we divide both sides by P, we are going to have A divided by P equals to P into 1 plus I raised to the power n divided by P. If this is done, this one is cancelled out. So we are left with A divided by P equals to 1 plus I raised to the power n. At this level, please, a divided by 2 will give an amount. At this level, we introduce log. When we introduce log, we are going to have log a divided by b. I'm not going to expand this. Why? Because there are amounts that when I divide, it will give me a value. I introduce log on both sides. So I have log AB, then I have log 1 plus I raised to the power n. There is a law of log that says log of, log of a to the power n is equals to n log a. So this therefore implies that log a over b will be equals to n log 1 plus I. Now this implies that n will be equals to, if I divide both sides, divide both sides by log 1 plus I. And it's going to give me log AB divided by log 1 plus I. This is the formula to calculate the duration given the acquired value, the capital, and the compound interest rate. This is the formula. Let's take an example. Let's take an example. Let's take an example. An amount of 100,000 francs is invested at a compound interest rate of 6%. So our P there is equals to 100,000 francs. CFA. Our compound interest rate is 6%, which is equal to 0.06. That's 6 over 100. And we have the acquired value 168,251 francs CFA. Calculate the duration of the investment, so N, we don't know. Now we need to continue. Recall that A, bird, A is equals to P into 1 plus I raised to the power N. Now we replace everything by their values. 168,251 equals to 100,000 into 1.06 raised to the power N. What is the first step? Divide both sides by P. So if I divide both sides by 100,000, I'm going to have 1.68251 equals to 1.06 raised to the power N. Now this is what I was talking about. We have to take A divided by P. It gives a single amount, a single number. So at this juncture, introduce log on both sides. Include log on both sides. So we are going to have log 1.68251 equals to log 1.06 raised to the power n. Let's not forget, log a to the power n is equals to n log a. So it therefore implies that log 1.68251 will be equal to n log 1.06. Now divide both sides by log 1.06. Log 1.06. Log 1.06. This will go, this will go. So n will be equal to, so log 1.68251 divided by log 1.06 equals to gives 8.9. 8.9, which is what? 9 years. That is the duration of that investment. That is the duration of the investment. That's the duration of the investment. 8.9, which is actually 9 years. 8.9, which is actually 9 years. Now let's calculate the compound interest rate. Let me wipe. Calculation of the interest rate of compound interest rate I. Now we start, recall that A is equals to B into 1 plus I raised to the power n. The first thing we do, we divide both sides by P. If we divide both sides by P, we are going to have A over P equals to P into 1 plus I raised to the power n divided by P. So P will cancel. Right? Now, at this stage, the easiest way to go, let me put this down. A over P equals to 1 plus I raised to the power n. You can introduce log, but it's going to be a bit long. At this level, the opposite of this power, if I want to remove this power here, I will take the opposite. The opposite of power is the root of that power. So, what we'll do here is that take the n root of both sides. And this is going to be what? The n root. So n A over P equals to n 1 plus I raised to the power n. Remember, this is an equation. This is equal to this. So anything we do here, if we do the same thing here, it still remains the same. So this n root will cancel this power n. So I'll be left with the n root of A over P, which will be equals to 1 plus I. We need I to be alone now. So bring 1 this way. So it means that the n root of A over P minus 1 will be equals to I. That is how we can calculate the compound interest rate. Please, these are steps to follow. These are steps to follow, and nothing more. They are steps. Not that if you are asked to calculate, you just put down this formula and you calculate. No. Immediately you put this down, as you're solving, you discover that you're going through these steps. Now, there is a case where if the power is negative, for example, you have been given the acquired value, you have been given the duration, and you have to discount. They get you the discount rate, and they want you to calculate, they give you the duration, they give you the principal, and they want you to calculate the discount rate. In that case, since the power will have negative, you will not be able to use the root of the power. You have to use log. So at this juncture, right? Let me say we have A into A divided by P, 1 plus I raised to the power n. At this stage, if we introduce log, on both sides, so we have log A over P will be equals to log 1 plus I raised to the power n. Remember, log an is equals to n log A. So it therefore implies that log A divided by P will be equals to n log 1 plus I. Divide both sides. Divide both sides by n. So if we divide both sides by n, we are going to have log A over P divided by n, which will be equals to n log 1 plus I, all of this divided by n. So n and n will cancel. So we are going to have log 1 plus I, which will be equals to log A over P divided by n. So your answer here will be log 1 plus I. That will be your answer. So to have 1 plus I, what do you do? Use anti-log. Use anti-log. And what is anti-log? Because you have this figure already on your calculator. Now, you are going to punch shift log and equals to. If you are using a calculator that's second function and not shift, you simply press second function log and you have 1 plus I. Then you can continue from there. So this is how you can calculate the interest rate using log. Let's pick up an example. That's going to be example number 4. At what compound interest rate will a capital double after 10 years? At what compound interest rate will a capital double? Wow. After 10 years. At what compound interest rate will a capital double after 10 years? So, the acquired value here will be 2p because the capital has to double now. Meaning, if we invested 10,000, after 10 years, what we should have in our account is 20,000. So it doubles. Now, at what compound interest rate? We don't know the compound interest rate, right? 10 years. The duration is 10 years. Now, the principal is still P. Let's record that A is equals to P into 1 plus I raised to the power n. But A is equals to 2P. So we have 2P into P into 1 plus I raised to the power 10. P is common now. We divide both sides by P. Bam, 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 bam. So we are going to have 2 equals to 1 plus I raised to the power 10. Opposite of power 10 is root 10. So we say take the 10th root of both sides. We take the 10th root of both sides. What do we have? We are going to have 10 of 2, 10 root of 2, and the 10 root of 1 plus I raised to the power 10. So this is going to be, we use a calculator. 10 root will be left with 1 plus I equals to. Now let's use a calculator. Use a calculator. You press 10, you press shift, you press raise to the power key, you press 2, then you press equal to. That's going to be 1.0717. So I'll put 1.071, 1.072. Let me end it, right? So I will be equals to 1.072 minus 1. So I will be equals to 0.072. If you multiply by 100, give us 7.2%. So that is the compound interest rate. 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 Now we are going to see another thing that is very, very important. Let me wipe the board. Proportional, proportional or nominal rate. Now, the calculation of the interest depends on the financial institution. Meaning to say, the compounding depends on the financial institution. Some financial institutions may calculate interest every year, meaning compounding is done 12 times a year. Some financial institutions may calculate interest 4 times a year. It means compounding is done every term, every quarter, or every trimester. A trimester, a term, or a quarter is a period of 3 months. Compounding may be done twice a year, meaning every semester. The financial institution may calculate interest twice a year. Now, with that, we can calculate the rates that are proportional for this period from the annual rate. Now, given an annual rate I, an annual compound interest rate I, and number of compounding periods per year, we call it small c. What does this mean? It means if interest is calculated 12 times per year, C is equals to 12. If interest is calculated every semester, that's 2 times per year, C is equals to 2. If interest is calculated 4 times per year, that's every term, every quarter, or every trimester, 4 times per year. Now, we can calculate the proportional semi-annual rate or semester rate. We can also calculate the proportional quarterly rate. We can also calculate the proportional monthly rate. Now, in some books, you will see ICure, that's IM and IS. But now, here I'm going to use numbers to identify the number of compounding periods per year. I think it's easier that way. Now, it means here the proportional rate here is simply the annual rate divided by the number of compounding periods per year. That's I divided by C. So it means the proportional monthly rate, proportional monthly rate, I'll call it I12 because compounding is done 12 times per year. It's going to be I divided by 12. The proportional quarterly rate, which I'll call I4. In some books, you see IQ or IT, will be I divided by 4. Meanwhile, the proportional semi-annual rate, I'll call it I2, which is simply I divided by 2. Now, if compounding is done more than once a year, we can modify our acquired value formula. We can modify our acquired value formula. Let's come this way. Our acquired value formula now will become E into 1 plus IC raised to the power NC. Now, what is C? C is still on the board. Number of compounding periods per year. What is IC? IC is the proportional rate, which is IC. I divided by C. That's a proportional rate, or let me write it this way. I see. I see. That's a proportional rate. Now, what is NC? N, first of all, is the duration in years. Duration in years. NC is the number of periods. Number of periods in N years. So far, the question that we have solved, they have given us annual component, annual interest rate, and the duration is in years. So we have calculated. We discover that the compounding period per year, which is just what, matches the duration. But we are going to take a series of examples where the compounding period does not actually match the duration, right? Does not actually match. So we have to make them to match, then we calculate the acquired value. Let me wipe the board and we go straight to that. Remember, I'm not going to wipe that formula. Example number 5. Example number 5. An amount of 6 million francs is invested for 8 years at the rate of 6% compounded semi-annually. Now, let's understand the question. At the rate of 6% compounded semi-annually. When the interest rate comes, it means it's an annual rate. Now they tell you how many times interest is calculated per year. 6% compounded semi-annually. The rate given is an annual rate, but compounding is done twice a year. But what if they would have said 6% per semester? You discover that in that case, the semester rate is already given. No need to convert. But this case, they said 6% compounded semi-annually. So it means that the interest rate given is the annual rate, the compounding is done twice a year. So let's look at how this goes. The principal here is 6 million. 6 million francs here. The annual interest rate is 6%, which is 0.06. But compounding is done 2 times a year. So we need to calculate I2, which will be I divided by 2. 0.06 divided by 2, which will be 0.03. N, which is our duration in years, is how many years? 8 years. So let's put down our acquired value formula. This will be P into 1 plus I2 raised to the power 2n. So this is going to be 6 million into 1.03 raised to the power 2 times 8. The 2 times 8 here is going to be 16 semesters, because in every year there are 2 semesters. So you discover that the number of periods, the number of semesters in 8 years is actually 16. So let's calculate another acquired value. Calculator. 1.03 raised to the power 16 equals to times 6 million. So that would be 9,628,000. 9,628,238.635 francs CFA. So that is the acquired value. I'll allow this one this way. Let me wipe this portion on the cup. And let's take example. The next example on this. Example number 6. Peter deposited an amount of 200,000 francs in an account that pays 2% per term compound interest for 4 years. How should How much, normally I miss much there, how much should be in his account at the end of this period? Let me read it again. Peter deposited an amount of 200,000 francs in an account that pays 2% per term. Per term means per quarter, right? Per trimester. Compound interest for 4 years. Now you discover that the interest rate now is not 2% compounded quarterly or termly, but it's 2% per term. So I've already given the termly rate. No need to convert here. So let's look at the way it goes. The capital as P is 200,000. The interest already is I4, the termly rate, which is equals to 2%, which is 0.02. Small c will be equals to 4. N is equals to 4 years. How many quarters are in 4 years? That's 16 quarters. That's 4 times 4. So we take A, acquire value, how much will be in his account? That will be 1 plus I2 raised to the power I4, sorry. 1 plus I4 raised to the power 4N. And this will be 200,000 into 1.02 raised to the power 4 times 4, which is equals to 16. So A in this case will be equals to 1.02 raised to the power 16 equals to times 200,000. 274,000, 577.141 francs CFA. That is the acquired value. And the last one now, that's question 7. Question 7. A capital of 1 million francs is invested for 25 months. I love this one. Calculate the acquired value at the rate of 10% compounded monthly. You discover that here, they have already detailed the period. It's no longer given in years, but in months. But now, the interest rate is given an annual interest rate, though compounding is done monthly. So we need to calculate the monthly interest rate. Now, let me use this section of the board. P is 1 million. Francs CFA. N, please permit me to write 12N, which will be 25 months already. Because here, 2 times 8 gives 16 semesters. 4 times 4 gives 16 quarters. So that is what it has already been given here, detailed. Okay, they are given an annual interest rate, I, 0.1. Though compounding is done monthly, so we need to calculate I12, which will be I divided by 12. So 0.1 divided by 0.12. What do we have there? Let me calculate. 0.1 divided by 0.12 equals to. That's going to be 0.8. I did not take calculator, please. It's 0.1 divided by 12. 0.1 divided by 12. 0.0083. I will allow it 4 decimal places, although it's 3.333. So it means that the acquired value A will be P into 1 plus I12 raised to the power 12N. We have I12 already, we have 12N already. So this will be equals to 1 million into 1.0083 raised to the power 25. So what is going to be our acquired value in that? So if I take this one plus 1 already equals to raised to the power 25 equals to times 1 million. It gives 1,230,000, 1,230,000, 560.886 pounds CFA. So that is the acquired value. So far we have seen how to calculate the acquired value, the present value. We have seen how to calculate the interest rate and the duration. We have seen how to calculate, to modify the proportional rate. We have seen how to modify the acquired value formula, right? And we are going to end compound interest part 1 here. For the part 2, we are going to see how to calculate the annual effective rate. We are going to see how to calculate the equivalent rate of interest. We are going to see how to calculate the equivalent of bills, and we are going to work out some mature application questions on compound interest. If it is too long, I'm going to still divide it into two, because I will solve application questions, many application questions on compound interest. But as of the next video, we are going to see annual effective rate, equivalent rate of interest, equivalence of bills, and some worked examples. Please subscribe to the channel, and don't forget the link to these questions will be in the description section of this video. Thank you very much for watching. God bless you. Please don't forget to share the link.